viewers, in this session we are going to discuss about measurement of length, mass, weight, area and volume. You have already learned about the basic units of measuring length, that is millimeter, centimeter and kilometer. To measure length exactly, we have subunits also. These can be used to measure larger and smaller lengths. Using for measuring greater lengths or greater than the standard unit of length, the meter, but less than a kilometer. These are 1 decameter is equal to 10 meter, 1 hectometer is equal to 100 meter, 1 kilometer is equal to 1000 meter. Just now you have seen that there are 3 units of lengths greater than meter which are used for measuring longer lengths. There are 3 units smaller than meter for measuring smaller length. They are decimeter, centimeter and millimeter. Therefore, 1 meter is equal to 10 decimeter, 1 decimeter is equal to 10 centimeter, 1 centimeter is equal to 10 millimeter. So, in all this you have seen 7 units of measuring length. These can be also observed in a decimal place value chart as shown below, that is thousands in kilometer, 1000 meter, hundreds 100 meter, tens 10 meter and in ones 1 meter, tens that is 0.1 meter, hundreds 0.01 meter, thousands 0.001 meter. We may remember the order of the units by this following sentence: King Harry died but mother did not cry much. Now let us see a problem. Change 3 kilometer, 8 hectometer, 4 decameter into meters. The solution is we have to change from bigger unit to smaller, so we will multiply 3 kilometer, 8 hectometer and 4 decameter, that is 3 into 1000 meter plus 8 into 100 meter plus 4 into 10 meter, that is 3000 meter plus 800 meter plus 40 meter, that is the answer is 3840 meter. Now we will see about expressing length using decimals. We can use decimals to express the length 37 centimeter 5 millimeter. We can express this in larger unit using decimals as 37.5 centimeter. We can express this in the smaller unit as 375 millimeter. We will see one example. Express 8563 meter as kilometer. For conversion of this, 8563 is to be divided by 1000 kilometer because 1 meter is equal to 1 by 1000 kilometer. Therefore, we will get the answer as 8.563 kilometer. Now let us discuss about measurement of mass and weight. Dear students, now we are going to discuss what is mass and weight. By now, as you all know that in our daily life, we often use the word weight in the place of mass. Units of mass are also used for measuring weight. Mass is the quantity of matter in a body and weight is the force with which the body is attracted towards the center of the earth. The standard unit of mass is the kilogram. The most commonly used unit of weight, that is mass, is gram. The smallest commonly used unit of weight, that is mass, is milligram and the largest commonly used unit of weight is kilogram. There are other units of mass such as quintals, tons, pounds, etc. that are used to measure weight. There are 3 units greater than gram as follows. 1 decagram is equal to 10 gram, 1 hectogram is equal to 100 gram, 1 kilogram is equal to 1000 gram. There are 3 units lesser than the gram and they are as follows. 1 gram is equal to 10 decigram, 1 decigram is equal to 10 centigram, 1 centigram is equal to 10 milligram. Let us observe there are 7 units of mass in a decimal place value chart as given below. In thousands, 1000 kilogram, in hundreds, 100 gram, in tens, 10 gram, and in ones, 1 gram. Tens will have 0.1 gram, and in hundreds 0.01 gram, and in thousands 0.001 gram. Therefore, we can say it 1 quintal is equal to 100 kilogram and 1 ton is equal to 1000 kilogram. Now, we will see the problem how to convert into grams. 5 kilogram, 4 hectagram and 9 decagram, 7 gram. From bigger to smaller, we need to multiply. Therefore, we are going to multiply 5 into 1000 gram plus 4 into 100 gram plus 9 into 10 gram plus 7 gram. Then it will become 5497 gram. Then we will see another sum 1486 milligram into gram. The solution is 1 gram is equal to 1000 milligram. Therefore, 1486 we have to divide it by 1000, we will get the answer as 1.486 gram. We will discuss then about measurement of capacity. You know, liquids have no fixed shape, they shape upon the shape of a container. To calculate the capacity of the liquids, we measure the capacity of the container. You know that the standard unit of capacity is liter. Same as in the case of length and mass, there are units greater than a liter. They are 1 decaliter is equal to 10 liter, 1 hectoliter is equal to 100 liter, 1 kiloliter is equal to 1000 liter. The 3 units smaller than a liter are 1 liter is equal to 10 deciliter, 1 deciliter is equal to 10 centiliter and 1 centiliter is equal to 10 milliliter. The above 7 units can be shown on a decimal place value chart as follows. The 1000 place 1000 liter and in hundreds place 100 liter and in tens place 10 liter and in ones place 1 liter. Then comes tens 0.01 liter, hundreds 0.01 liter and in thousands 0.001 liters. Now, we will see a sum how to change into liters. 2 kiloliter, 8 hectoliter and 3 decaliter, 9 liters. For this conversion, we have to multiply 2 into 1000 liter plus 8 into 100 liter plus 3 into 10 liters, we have to add 9 liters. We will get the answer as 2839 liters. Now, we will see another sum how to convert into milliliters. You consider a problem as 8 deciliter. We know the solution as 1 deciliter is equal to 100 milliliter. Then 8 deciliter is equal to 8 into 100 milliliter, we will get the answer as 800 milliliter. Now, we will see how to calculate area and what is area. Dear students, now we are going to learn what is area. Look at this closed picture. All of them occupy some region of a flat surface. Can you tell which one occupies more region? The amount of surface enclosed by a closed figure is called as its area. Now, we will see about comparison of areas. When the given surfaces are the same shape, we compare them by placing over one to other. Given below, there are two pentagons A and B. By placing them one over the other, we find that B is larger than A. Thus, we can say that the area of B is larger than that of A. Consider two circles C and D of radii 3 cm and 4 cm respectively. Obviously, the surface enclosed by the circle D is more than enclosed by circle C. Thus, the area of circle D is more than that of the circle C. Sometimes it becomes difficult to compare the area of two surfaces by simply looking at them, particularly when the figures are of different shapes. Look at the figure E and F of a rectangle and a triangle respectively. Obviously, we cannot compare the area of E and F until and unless we measure them in definite units. For that, we need units of area. We will see units of area. We use a square of side 1 cm to measure area. The area of this square is 1 square centimeter or 1 centimeter square. Area of a rectangle and a square. Area of a square is equal to A squared, that is A into A. We can tell it as side into side. Then area of a rectangle, that is length into breadth. From this we can find length as area divided by breadth, and we can also calculate breadth by area divided by length. Now we will see about volume. See these pictures. Have you seen this picture? Each of these solids occupies a space. Bigger objects occupy more space and smaller objects occupy less space. So, we can say that every solid occupies certain amount of space. The amount of space each solid occupies can be measured in a special way, that is called volume. To understand this, let us perform an experiment. Area of a square is equal to A squared square units. Area of a rectangle is equal to B into H square units, that is breadth into height. Area of a circle is equal to pi r squared square units. Area of a parallelogram is equal to B into H square units, that is breadth into height. Then coming to area of a rhombus, that is breadth into height, we can also denote it as B into H square units. Area of a right angle triangle, that is half into breadth into height square units. Area of a equilateral triangle, that is square root of 3 by 4 into A squared square units. Area of a scalene triangle, that is square root of S into S minus A into S minus B into S minus C square units. Area of a obtuse triangle, that is half into B into H square units, that is base into height. Area of a isosceles triangle, half into breadth into height square units. Take a transparent glass and pour some water into it, say about half of it. Then observe its level and mark on the glass surface. Now drop a piece of stone in it. Again observe water level and mark it. What do you observe? You observe that the level of water in the glass has gone up. Now this experiment shows that the stone has displaced some water. which is equal to the amount of space occupied by it. This is so because stone occupies certain space. That is, volume of a stone is equal to quantity of displaced water. Therefore, the amount or the measure of space occupied by an object is called its volume. Now coming to cuboid. Cuboid is a solid figure with 6 rectangular faces. Its height, length and breadth may be different or may be equal. Now coming to cube. Cube is a solid figure with 6 equal square faces. All the edges are equal. It means height, length and breadth are equal. Now we will see about the volume of cube and cuboid. Volume of cube is equal to side into side into side. Then volume of cuboid is equal to length into breadth into height. Now in this session we had seen about the measurement of length, mass and weight. I hope you all enjoyed this session. Thank you.